Now, the next step, just before setting the PID again, is to check the maximum velocity that can be commanded to this motor by the PID driver mode. Because the PID driver mode will send a target velocity command with radians per second. So we want to check what's the maximum velocity that this can send to this motor. And there are two things to check. The first thing is I'm going to go to this tab, the PID tab. So now there's this parameter I want us to take note of. This is W max. Now what is W max is saying? It's just telling you this is the maximum velocities the module can command the motor. That of this is not concerned about what actually the motor can take, but rather what the module can command this motor and it's permitted for proper operation on the module. Because the module is doing things like filtering, also doing PID operation, and also doing reading bipolar pulses using interrupt. So it needs to note the how it's doing some of all these operations. So that's what it's doing. Now the way the module calculates its pulse per encoder, its velocity, the way the module calculates its velocity is using time difference between two pulses. So because of that, it's not very good for high frequency applications. So there's a need for that limit so it doesn't affect the process on the microcontroller. And this is actually the formula that was used. This was called the allowable angular velocity. Now you don't need to worry about how to calculate it because that's what it's doing that automatically on the module. Module is doing that. So this 2 pi times the allowable frequency per tick, which is 2000 hertz. That's so just for a safe operation. So that's what was chosen there. So that you understand what it's actually doing, I'm going to change the encoder PPR. Let me go back. Let me change this on like 800. I want you to notice something. See that this was changed to 16. So once I change the PPR, it runs this particular formula. It runs this particular equation on the driver model, and then to compute the maximum allowable velocity that can be commanded to the motor. That's basically what it's doing. So I'll change it back to 1092. So once I said that, you notice that everything is changing backward to paper band, which is 12 radians per second. Now understand something that what this is saying that this is what the maximum the module can command the motor, not necessarily what the motor can receive based on its data sheet or based on what the motor can actually accept by itself. So to calculate to know what the motor can actually accept by itself, we'll go back to this encoder term and just enter the high WM. Just enter PWM of 250. Yes, so now you are going to start the motor and watch this velocity. Yeah, you notice everything's about 9, around 9. Well, 9 radians per second. So there are 9 radians per second. So it means now we can now change this value back towards 9 radians per second, which we know that should be the maximum that this motor will readily accept. Because anything greater than 9 you will not get. The motor cannot work anything greater than this 9. That's what this is now saying. So that's how to set it. Now just to take it up, so let's assume that when you did the 250, when you ran what the motor can take, let's assume it was around 20. Yeah, it reads 20 radians per second. Let's assume it reads 20 radians per second. I should enter 20. It will still remain at that 12. What is just say that the module will not allow it to exist, so that whenever it's running its PID operations and it's filtering, it will not hinder any soft process there. That's exactly what it's doing. So regardless of that, so that's exactly what is doing. So just take note of like we can set it lower than that. So I'm turning back to the knife. So now we know that our motor is properly set. The maximum velocity has been set. That is that.